Rainbows are one of the most beautiful sights in nature, and we usually see it on a rainy day. But you will be surprised to know that you can even see it on sunny days if you're near waterfalls or fountains. So what is really required for the rainbow to be formed? The two things that are required for the rainbow to appear are white light and tiny water droplets. The latter is quite important for its formation. In the rainy season, many water droplets are present in our atmosphere, and hence we mostly see the rainbow in this season. Okay, so how do these two combine together to form a rainbow? Well, the formation of the rainbow results from the simplest of optical phenomena known as refraction and total internal reflection. Yes, among these two, we know quite a lot about refraction of light. Okay, so let's see how sunlight and droplets interact with each other. First of all, suppose that we're looking up at a rainbow from some point on the surface of the earth. We see the colors of a rainbow in order: red, orange, yellow, green, blue, indigo, and violet from top to bottom. We might not be able to see indigo that well because our eyes are not quite sensitive to that color. Now, as I told you, rainbows during the rainy season are formed due to the presence of water droplets in the atmosphere. There are many of these where a rainbow is formed. Say we are only looking at the red part of the rainbow. The simple reason that we're able to see anything around us is because the light from that particular object is traveling to our eyes. Similarly, the red light from the upper part of the rainbow is traveling to our eyes, enabling us to see it. But where is this red light coming from? In order to understand this, let's consider a single water droplet from this red region and suppose the white sunlight is incident at this point on it. The angle at which the light is incident is very important, and I will tell you why in a little while. It will reflect some of the light at the boundary and refract some of it. The reflected light is white light again, and it's going away from our eyes. So we ignore this as this light does not help in forming rainbows. But we know that the white light of sun is composed of 7 primary colors. It's VIBGYOR. And we also know that the prism will break this white light into its constituent colors when allowed to pass through it. A water droplet behaves exactly like a prism. It disperses the white sunlight at the entry point. What happens next? This dispersed light falls onto the rear side of the droplet, and each light color is again refracted by different angles. But wait a moment. Look at this point. Why is the light getting refracted in the same medium? Well, you must have assumed that it will pass through the air and not back through the water. This is happening because of an optical phenomenon known as total internal reflection. Let me quickly enlighten you about this. We know when the light travels from an optically denser to an optically rarer medium, it bends away from the normal. And greater the angle of incidence, greater will be the angle of refraction. But here's the interesting part. There is some angle called the critical angle at which the refracted ray will be perpendicular to the normal line. That's right. At this angle of incidence, we can see that the refracted ray is perpendicular to the normal. And if I further increase the angle of incidence, then the refracted ray will now travel through the incident medium. So if you notice, the ray is actually reflecting in the same medium. The same thing happens here in a water droplet as well. This angle of incidence at this surface for each colored light is such that they all bend in the same medium. So these different colored rays are now at the air-water interface again for the third time. This time, however, the total internal reflection does not occur and they bend in air. But notice that all the colors in air are now separated by quite an amount. The 3 refractions create the larger gap between these colors. All the droplets in this red portion of the rainbow behave in the same way. But wait a moment. These droplets are refracting the light of all colors. Then why are we able to see only the red color in this region of the rainbow? This is because only the red color from this region reaches our eyes. All the other colors are refracted at such a large angle that they do not reach our eyes on the ground. Same thing happens for the remaining regions of a rainbow as well. For instance, droplets present in the violet region also send the light back in the same way. But only the violet color reaches us and the remaining colors are not visible. I hope that you now have a basic understanding of how a rainbow forms in the sky. We